Hello everyone. Thank you for coming to this tutorial. So far we have seen lots of methods to create tensors. Here I'm going to talk about different methods to create tensors, which PyTorch calls it as tensor like other tensors. So it means that we already have a tensor and we want to create a tensor which the shape is similar to the previous tensor. So the first one will be rand like. So let's create a random tensor. So rand equals torch dot rand. We already saw it, 3 by 4. And here we already created a tensor. We can also print it, rand. Okay, so this is a random tensor. Now we want to create another random tensor, which looks like this rand tensor from the shape. So to do that, we don't need to create another torch.rand. We can simply say that rand like. We can say that it's like torch dot rand like. We can use a rand like function, and like what tensor? This one, rand. Now let's print it, rand like. This is another tensor that has 3 rows and 4 columns, 3 by 4, the same as the previous tensor, but definitely it's a random tensor and has different elements. Another method is rand n like, which we already saw it previously. So here, as a recap, it was a tensor. It creates a tensor with random values sampled from a normal distribution with mean of 0 and variance of 1. So here we can create a tensor. Let's create another space for that. So let's create, we have already a tensor, rand. So now here, rand n like is equals torch dot rand like rand, and let's print it, rand and like. This is a tensor which its shape is similar to our previous tensor here, but the mean is 0 and the variance is 1 from the elements. And another method is rand int like. So let's create that one, rand int like equals, let's again use the same tensor that we already have. Here, torch dot rand int like, and it requires a tensor, rand, which we already have it, and it requires a higher band and a lower band. So we can say 10 and 15. Now print rand int like. So it creates a tensor which the shape is similar to our rand tensor 3 by 4, and the elements are between the higher band of 15 and the lower band of 10, which 11, 12, 13, and 14. Another method to create tensor-like is zero-like tensor. So let's again use our rand tensor as our base tensor, and here we can say that for zero-like is equals torch dot zeros like, and for that it requires a tensor which we can use rand, and let's print it zero like, or better to change it as zeros to keep the consistency. So it creates a 3 by 4 tensor which all the elements are 0. And also we have ones, so ones like equals torch dot ones ones like, and we can pass the same tensor as rand, and let's print it ones like. So here it creates a tensor that is similar to the rand from the shape, but all the elements are 1. We have also another methods here that we can use them to create a tensor, empty like and full like. So for empty like, we also saw that here to create empty tensor. Let's take a look at it again. Empty and full. So for empty, we just created a tensor that created a tensor with garbage values, and for full, it takes a shape for that tensor and also a value for that. So now let's move on to this section and see how we can create these tensors. So empty like equals torch dot empty like, and it takes a tensor. We can use the same tensor that we have and print empty like. So it's just a tensor with empty values. And for full like, we can use torch dot full like. So here it needs a tensor rand and also a fill value. So let's say 100, and let's print it full like. All right, so it prints and creates a tensor which the shape is similar to the rand 3×4, and it filled by 100, the value that we already prepared here. Let's talk about these two functions, and in the next video we can talk about attributes. So these are two functions that are very useful in saving and loading serialized tensors, which are very useful in machine learning. Load and save. NumPy also has these two functions. So to use them, we can create a tensor. Let's call it x. Torch dot. Let's use a range. We can use 100 as creating a 100 tensor. Let's print it x. So it creates from 0 to 99 100 elements. Now here we can save this to our directory. So let's say torch dot save, and here it gets an object which is a tensor x. In this case we want to save this x tensor we already created, and it needs a name for that. So let's say my tensor, and we can save it with a extension like PT or whatever. Now let's save it. So it's already saved. Now we can load it. So let's say my load equals torch dot load, and what we are going to load is this tensor that's already created, my tensor.pt. Because I am using Google Colab, so they're in the this directory that I'm working here. It was saved here. So let's now it was loaded. Now let's print it. Print my load. Now you can see we created a tensor here. It's kind of a 1D or serialized tensor, and then we saved it under this name. It was saved in our directory, and then we load it. Now we print it. So this is a good function to save our weight or whatever data that we have, then we can use them in our future programs. All right, thank you for watching this video, and sorry these videos became very long. See you in the next video.